Hi Year 10 and welcome to the last exercise that we're going to be doing on Chapter 1. Today we're going to be dealing with spheres and finding the volume and the surface area of them. You need to remember that spheres are like a basketball or a tennis ball or something like that. They're round and solid, three-dimensional, and when we deal with the surface area, we measure in units squared, and when we deal with volume, we must deal with our units cubed. So you can see on the screen here, we've got our formulas for our surface area. There's our sphere, we've got a radius, and the formula for the surface area of a sphere is 4 times pi times r squared. The formula for the volume is a bit more complicated. So there's our sphere with its radius. The formula for the volume of a sphere is 4/3 times pi times the radius cubed. So you're allowed to put these formulas on your formula sheet. It's a matter of just knowing how to use them and when to use them. Here's our first example. So we need to find the surface area and the volume of a sphere that has a radius of 23 centimetres. So I've put a picture there for you. There's your radius of 23 centimetres. Be careful, because if you have the diameter, you have to halve it, but this is a radius question. So the first thing we're going to do is find the surface area. So I've written the formula down. And notice with the surface area, I put in small writing down the bottom sphere, so I know this is the surface area of a sphere formula. And it's 4 times pi times the radius squared. Well, I know the radius is 23, so it's 4 times pi times 23 squared. I put that straight into the calculator. And the question says to give the answer to 2 decimal places, so there is my answer, 6,647.61 centimetres squared, because it's an area, surface area question. To find the volume, there's our formula, 4/3 times pi times radius cubed. Now we know the radius is 23, so it becomes 4/3 times pi times 23 cubed. Put that into your calculator, and to 2 decimal places, there is your answer, 50,965.01. So as long as you have the formula and your calculator, these ones are actually quite easy to do when they're in their simple form. Let's try our second example. This is a bit trickier because it says to find the radius. We don't know the radius of the sphere, but the sphere has a volume of 18 centimetres cubed. Well, we're dealing with volume, so let's write down the formula for the volume of a sphere. The volume is equal to 4/3 times pi times r cubed. But I know the volume is 18, so over on the left side of the equal sign I can say 18 equals 4/3 times pi times r cubed. Now this next step can be done several different ways. I'm going to look at the 4/3 and times it to pi on the calculator. So if you do 4/3 times pi, I'm just going to see what that equals as a decimal. And so I'll get 18 equals about 4.188790205 times r cubed. Now you'll notice I've got squiggly equal signs because it's rounded off now because I used pi. That's okay. If you don't put the squiggly signs, that's fine. But make sure you put it to quite a few decimal places. Now the whole idea is to find r. So to get the r cubed at this stage by itself, we're going to do the opposite of timesing, which is dividing by the 4.18879020205. And there we have it. So when I divide, it's going to cancel on the right hand side here, and on the left hand side I've got 18 divided by that messy decimal. Well, that can be done on the calculator, and when you do that on the calculator you get 4.297183463 when you write the full answer down, and that's what r cubed equals. I've just switched the r cubed over to the left side and the answer to the right side. That's okay. The way we undo to the power of 3 is use the cube root button. So we're going to take the cube root of both sides, and on your calculator the cube root of 4.297183463 is equal to about 1.63 if we go to 2 decimal places. Notice I didn't go to 2 decimal places early. I waited until I got to the answer. So there's the radius of my sphere. That's a much trickier question. They're not very common, but you still need to be able to do questions that are a little bit trickier. Our final example is a composite shape where we actually have a cone and half a sphere joined together. So when we look at this shape, the first thing I'm going to deal with is the surface area. And I'm going to find the surface area of the curved part of the cone first. Let me shade it in. Just the curved part. So we're not actually counting the circle. So it's like a cone that's open. There's no lid. And that's why the formula is pi rs, because the formula for a cone is pi rs plus pi r squared. But we're not worried about the pi r squared because there is no circle on this one. It's open. That circle's inside the shape, so we can't have a surface area of that. So it's pi times the radius. The radius is 8. S stands for the slant height, which is the height that's on a lean, on a slant. The slant height is 13. So it's just pi times 8 times 13. Put that into the calculator and there's my answer to 2 decimal places. So that's the surface area for the curved part of my cone. I now need to do the half cylinder. Sorry, not the half cylinder, the half sphere. So let's actually have a look at that. There's our formula for half of a sphere. Remember, the surface area for a full sphere is 4 pi r squared. I could have just written that formula and written divided by 2 because I'm halving it, but I chose not to do it that way because I know I know that half of 4 is 2, so I've just halved the 4. So 2 pi r squared gives me half of the surface area of a hemisphere, or half the surface area of a sphere, 4 pi r squared gives me the full surface area of a total sphere. Now I know the radius is 8, so it's 2 times pi times 8 squared. So I've just shaded in what we're finding over here in green. 2 times pi times 8 squared gives me 402.12 centimetres squared, which means the surface area of this shape are those two answers added together. We add them together and it's a little over 700. So that's the surface area part done. Now we've got to deal with the volume. Now, the volume. Well, let's find the volume of the cone first. Now the formula for a cone, the space inside a cone, the volume is 1/3 of pi r squared h. Okay, you can have that on your formula sheet. We know pi, we know r, the radius is 8, but we don't know h because h is the height. Not the slant height, the straight up and down. It's called the perpendicular height. So in order to find the height, I'm going to have to do a little bit of trickery using Pythagoras. Now you can see I've put in a triangle there. You can see the radius. There's the hypotenuse. I need to find the height. So I'm finding a shorter side. So using Pythagoras, h is equal to the square root of 13 squared. Take 8 squared, put it into your calculator, and to 2 decimal places the height's 10.25, which I can now use in my formula over here. So it becomes 1/3 times pi times 8 squared, because the radius is 8, times 10.25. So let's type that into the calculator, push equals, and there's your volume for your cone. That's the purple part here. Now we need to find the volume of the hemisphere, the half sphere. Now the formula for the volume of a sphere is 4/3 pi r cubed. So I could use that formula and then divide by 2 because it's half of a sphere, or I could do what I've done here and say half of 4/3 is 2/3. So the volume of a hemisphere is 2/3 of pi r cubed. And I know the radius is 8, so it's 2/3 times pi times 8 cubed. Put that into the calculator, and the answer is a bit over 1,000. So the total volume is found by adding those two numbers together, and works out to be 1,759.29 centimeters cubed. Notice the volume is measured in centimeters cubed and the area is measured in centimeters squared. Well, that's it. You need to finish off exercise 1I today and homework if it's not finished. Next lesson will be revision, and the lesson after that you'll be doing a test on chapter 1. Enjoy